And I would extend my welcome tonight at the dinner time. I would like just to make it very briefly, since we have an invited luncheon speaker and would like to start in time. We had a marvelous morning, as many of you have attended the 2 tutorial sessions, and also more tutorial sessions to come in the afternoon. And I would like to see your participation, since we offer these tutorials free of charge, which is a good privilege for any attendance to this conference to attend those tutorials. And tonight would be more in the panel sessions and welcoming remarks from the president of IEEE, he's not here at the moment, and also the president of IEEE Canada. And would be the panel session that number of people involved in. Just let me to welcome you and for your participation in the beautiful Montreal. And let me to introduce to you the keynote speaker for the luncheon, Professor Jamal Deen, who is a senior Canada Research Chair in Information Technology, Director, and Micro and Nano System Laboratory, Electrical and Computer Engineering Department. Jamal, I have a quite lengthy bio for you in the pamphlet. I would say I would leave it for you guys to really get closer to all the contributions that Professor Deen has been doing, and his contribution to the direction of the healthcare and so on. His title of his talk is Ubiquitous Healthcare, Smart Homes for Elderly. I would like to call on Dr. Deen to come and start his talk, and after that I will call on Bria, Dr. Bria, who is invited Dr. Deen to thank him. Okay, welcome Dr. Deen. Thank you.
Good afternoon, everyone. Bonjour, mesdames et messieurs. Today I'm going to be telling you about some work we've been doing in the past several years on ubiquitous healthcare, smart homes for the elderly. But before I do that, I thought I'd introduce myself just a little bit. Because I have a sort of an interesting background. When people meet me, they usually ask me, where are you from? So first I will answer that question. So where am I from? So I'm from a small country in South America. It was originally British Guiana. It's now Guyana. And if you look at this map here, it's in the north part of South America, just north of Brazil, and east of Venezuela, and next to 2 other Guianas, Dutch Guiana and French Guiana. French Guiana is famous these days because that's where the Europeans launched their satellites from. It's a very nice country, as you can see. It has lots of interesting things. So we have really nice parliament buildings. We have very nice wooden buildings for law courts. We have the tallest wooden cathedral in the world. And we have very nice hotels that are just next to the beach. So I'm also making some advertisement for my home country. Next, we have one of the steepest drop waterfalls. It's 250 meters high. It's a paradise for all types of people, but women in particular enjoy trekking through the forest. You can see them here, sleeping in hammocks under the tree, so it's a really nice natural lifestyle. You can see lots of wildlife, so these are howler monkeys that are unique to South America. You can see green tree python, which is different from the normal pythons you see. So these are pythons that live in the tree during the day, and then they come down from the tree at night to hunt. So it's different from the pythons you see, for example, in Asia or Africa. And of course, we have jaguars and beautiful beaches with coconut trees, and you can have a picnic here. I myself grew up just outside the capital city. So the capital city is Georgetown. You can see the beach near to the ocean. This is a river. And my high school was just a few hundred meters from the beach. So it's a really good place to go to high school. This is part of my high school. Labs were in the first floor, and the second floor and third floor are classrooms. My high school was very unique. Each year they take in 100 students who write the national exam, and those 100 students stay together for 5 years or 7 years. So at 5 years there's a national exam, and if you pass, you can continue for 2 more years. So in my class, we had 26 people, and we were together for 5 years. And of those 26, one has passed away, and 23 of the 26 are in communication with each other up till today. So this was from the 60s and 70s to today. And most of them have done very well. 6 of us work at universities, 5 of us have their own business, 13 are artists, bank officials, clinicians, engineers, lawyers, etc. And this is where we live. So we live in my home country, Belize, Brazil, Canada, Jamaica, United Kingdom, and USA. So we're spread out over many countries in the world. So this is the beach where my high school was close to, and this is where I lived. And this is where I worked for many years. So we had a high school here, and I was a high school teacher for many years. This is one of the streets of our capital city. You have cars on the left, cars on the right, and you have a pedestrian walkway in the middle that is covered by trees. So it's really very nice to live in such a tropical country. Now the second thing I want to tell you is what is not normally introduced of a university professor, and this is related to our non-academic activities. So what sort of non-academic activities I've done in my life? So for many years, when I lived in British Columbia, I was a science fair judge for the Lower Mainland. And this was a very good experience to actually interact with high school kids. So I did this for many years. And then when my kids were in primary school, I volunteered and I taught a mathematics and science enrichment program for several years. And this was also very interesting because you're teaching children between 6 years and 9 years. And us, as university professors, if we think it's challenging to teach students that we have now, my suggestion is to try to teach 6 to 9-year-olds. You'll have a different appreciation of what a challenge means. I also, when my kids were in high school, they had to volunteer as part of the high school program. So we spent several years volunteering at a homeless shelter. This homeless shelter is called Mission Services. And as a volunteer, you have to cook, you have to serve, and you also have to clean. So I have experience being a judge. I have judging science fairs. I have experience teaching very young kids. And I have experience working with disadvantaged people or people who have fallen in hard times. And this sort of experience really changes your perspective on things and how you actually interact with people. So many of you who live in Ontario and who have children may have such similar experiences. In addition, when my kids were in school, as parents, we were also actively involved in the school. So I was an executive member of the Home and School Association, and I was also the school's representative in the Carleton Council of Education when we lived in Ottawa. This gives you a very good chance to actually see what are the challenges that teachers face and how parents can help the teachers address many of those challenges and how we can work collectively to actually improve our school system. So these were not the only things that I did. I was also a soccer coach for many, many years. So this is my youngest son when he was there. And I had very good assistant coaches to work with me. And I also, in the past several years, have been giving many public lectures. And this is an example of the type of public lectures I've given. It's not very scientific, and it's tailored so the sort of common university person, or even the common person can understand what I'm doing. So this is a brief background of where I'm from, and some of the non-academic things I've done in my life. Okay, so now we get to the, so what are some of the things we're most known for? So in the last, I would say, 25 years, we've worked in some key areas, and one of those key areas is the noise. So many people who work in communications were going after signals, we went after noise. And we were quite successful because the noise model that we developed was actually put into the most popular simulator of all time, and most wireless products that are made today use the model we developed in the 90s. We also developed a reliability prediction system for Nortel, and this enabled Nortel to actually have a very big advantage in the 90s in manufacturing 10 gigabit fiber optic transceivers. And we developed some patented devices and circuits that have been used in industry in the past. So this thing has almost died in me. Okay, so now let's get to the talk. So the talk is ubiquitous healthcare smart homes for the elderly. And I'll first start explaining why we're interested in this type of research. As researchers, it's always important to know why you're doing what you're doing. Then you can figure out how to do it, and then you can figure out what needs to be done, etc. So the reason we're interested in this is that if you look at the healthcare in most countries, it's actually linked by three important parameters. Those parameters are cost, demographics, and quality. So for example, if you want better quality healthcare, the cost is going to go up, and this is a problem for most provincial and national economies. Since the population is aging, they will demand more healthcare, and the cost for the aged population increases. So if you want to change any one of these legs of this tripod, the other two will be affected in a significant way. Right? So people want better quality of care or better quality of life. We have an aging population, and we have a rapidly rising cost for healthcare. The second thing is the economic argument. So what is the economic argument? This is an argument that is taken from this consulting company called Frost & Sullivan, where they plotted for many countries how much money they're spending per year, and they broke it down into public and private. So the dark part is public, the light part is private. And if you look at Canada, about 2/3 of the costs come from the public, and 1/3 comes from the private. Right? And in the red line is a fraction of GDP. So in Canada, the fraction was about 14% in 2008. Now if you compare this, you think I'm too far? Okay. So if you compare this with defense spending, you see that healthcare is much, much more than defense spending. Now if you fast forward to a few years into the future, or a few decades into the future, so this is in 2050, if the current trends hold, so this is the trend at which healthcare is increasing, most countries will be spending 17 to 30% of their GDP. So this is 30%, this is 17%. And clearly this level is unsustainable. So us as engineers and as scientists need to figure out how we can help to develop solutions to address this big problem that is coming in the future. So next is the demographic problem. So for the demographic problem, we're all growing older, and actually it may surprise you, we're growing older at an astonishing rate. So what does this mean? You know, everybody ages at the same rate. So why do I say we're growing older at an astonishing rate? The reason for this is that the rate at which we have older people increasing is faster than the rate at which we have younger people being born and being put into the population. So I'll say it again. The rate at which we're bringing in new people into the population is far less than the rate at which we're keeping older people into the population. So overall, we're growing older at a faster rate. So this is really very important. For example, by 2030, the US will have more than two times the elderly population who are beyond 65. So it will grow from 35 to 71 million people. And within 10 years, for the first time in human history, so for the many tens of thousands of years of human history, the people who are beyond 65 will outnumber the people who are less than 5 years old. So this actually ties in with this first point that I made here. And this is really very important. So many of us will be in this situation within 10 years. If you look at some country, many countries, and this is an example that I took from Japan, this is what the population looked like in 1950. This is a normal triangle, or we say a normal pyramid. This is what it looked like in 208, so you see the middle has grown. And this is what it will look like in 2050. So you take this pyramid, you turn it upside down, and now you have far more people who are beyond 65 than you have people who are below, in this case, 12 years old. So in 1950, it was close to 40%. 100 years later, it's going to be less than 10%. The amount here was 5%, and here it's going to be 40%. So you can see the big shift in demographics. And this is something that is true for most of the developing countries, and in particular the developed countries. So countries like Japan, China, Korea, Italy, Spain, even Canada have problems like these. I'll tell you the specific situation with Canada in a short while. So this is taken from our local newspaper, the Hamilton Spectator, and it had this title a couple of years ago. It says a wave of 10 million baby boomers is turning 65, and they are about to change the way in which we live. And if you look at them, they're healthier, they have more disposable income, they're more interested in recreational activity, so you can see very nice healthy body with an aged face. And if you look at some of the details, so seniors are now 5 million, and by 2036 it's going to be 20 million. This is going to have a big impact on healthcare, on the pensions, and in the social program. Currently they make up 14% of the population, but they use 40% of the hospital services. And in Ontario, they use up 45% of the provincial budget for healthcare. Now, one of the things we can do is we can start bringing technology to bear to address some of these problems. And this is a very good saying that was taken from Desmond Tutu. What he said is that e-health gives us the best means of providing accessible health care to the poorest and the most vulnerable. So not only for the advanced societies, but also for the poor societies. Okay, so what I'll do is I'll walk you through a few scenarios. So the first scenario I want to walk you through is related to walking and its implications for falling. And there's a lot of people working in this area. In fact, companies are already beginning to make products that are specifically addressing this problem. This is a very big problem. You may not know it, but it's a very, very big problem. So this is a company that is called HIPS, and this company is making hip protector in the underwear that are particularly targeting the elderly, so that when they fall, they will not fracture or break the hip and the upper thigh, which is where most fractures and injuries happen when elderly people fall. Now, why I'm interested in walking and falling and life expectancy? So if you look at most people, our balance decrease as we age. And according to the Center for Disease Control in Atlanta, 1/3 of the elderly population, so this is 1/3 of the people who are beyond 65 years old, will experience one fall per year. 30 to 50% of the people who live in long-term residences fall per year, and 40% of them fall more than 2 times per year. So falling is a really, really big problem. In the United States, currently, the economic cost related to falling is more than $75 billion per year. So this is not only a big medical problem, but it's also a very, very big economic problem. Now, because the elderly are very susceptible to fall, many of them develop a fear of falling. And this has actually a negative implication. The negative implication is that because they fear falling, it limits their physical activities. When they limit their physical activities, they actually lose physical strength, they lose flexibility, and the fear of falling actually results in an increase in the risk of falling. So this is really very important. A fear of something happening actually results in that thing having a higher probability of happening. And it's really important that these seniors maintain their physical activity so that they can prevent fall and injury. So the fear causes a bigger problem about what they're fearing. Now, this walking sounds simple, right? But walking is really very important, because when we walk, We have to expend energy. It requires control of our movement. We require support of our muscles and our bodies. And when we walk, it places demands on multiple organ systems. Your heart should function properly, your lungs should function properly, circulatory system, nervous system, etc. So all these systems must function properly if you walk properly. If you don't walk properly, so for example, if you start slowing down, so a slowing gait, what does it imply? It implies that there's a damage to one of these internal systems. So there's a damaged system, and because there's a damaged system, people who have problems walking have to actually spend more energy walking. So if you're not physically fit and you walk with somebody who's physically fit, at the end of some distance, the person who's physically fit will be okay. He will not be out of breath. The one who's not physically fit will be out of breath. They will be breathing faster, etc. Right? So walking is a very good metric of what's happening internally. Now, not only this, a few years ago there was a large long-term study that was done. And what it showed is that the walking speed for your specific age group was a very strong predictor on how long you're expected to live. So I'll say that again. So for example, let's say you're from 65 to 75. And within that age group, you're expected to walk, let's say, 1 meter per second. If you walk faster than 1 meter per second, you have a higher probability of living longer in a healthy way. If you walk less than 1 meter per second, you have a low probability of living long and a low probability of being healthy as you continue to live. So just that simple metric of walking speed is a very good indicator not only of your state of health, but the possibility of you having a longer and healthier life. Now, what have we been doing in this research area? So what we've been doing is developing something called an age-based walking pattern analyzer. So what is this? This is a technological system that we can use to recognize our walking patterns. So for example, the elderly has a certain way in which they walk. It's very different from adolescents. So if you look at how they walk, it's very different from the elderly. And if you look at how children walk, it's also different. So this is why we're interested in an